Hey folks, I've got a couple of questions about a MyMathLab question that involves using the derivative of the inverse cosecant function. So I thought I'd do a quick derivation of the inverse cosecant function's derivative, and then we'll answer the MyMathLab question in a separate video. So let's say we had the function y is equal to the inverse cosecant of x. So what's our strategy here? Well, we've seen this a couple times now. Our strategy is to take this cosecant function and write its equivalent trigonometric function. Okay? As I've said before, remember you take the inverse trig function of a ratio and it returns an angle. So we could think of this as an angle is equal to the cosecant inverse of a ratio, and we'd like to give the equivalent trigonometric fact. Well, that would be that the cosecant of an angle needs to be equal to a ratio. So the equivalent cosecant fact over here is that the cosecant of y would be equal to x. Now what are we going to do? Well, now we're going to implicitly differentiate both sides. And we'll take the derivative of the right-hand side. And so we have the derivative of the cosecant of y is equal to the derivative of just x. On the right-hand side, we get 1. And on the left-hand side, let's see here, what was the derivative of the cosecant? Well, it was the minus cosecant y times the cotangent y. If we go ahead and, and then by the chain rule, we multiply that by the factor y prime. Careful there, I almost forgot that. Multiplied by the factor y prime. So now we're going to solve for y prime, so I'm going to divide these two expressions over to the other side, and that gives me minus 1 over the cosecant of y times the cotangent of y. Well, I still like to do these with the right triangle. So if I go back to this statement right here, where we say the cosecant of y is equal to x, let's go ahead and draw the equivalent triangle to that trigonometric statement. So I've got a right triangle, and I've got to label one of these two angles by my name of the angle. So the name of the angle is y, so there's y. And then let's see here, I'm having a hard time remembering. The cosecant of y, well, I'm not sure if I can remember that, but that's 1 over the sine of y. And remember that the sine is the what? It's the opposite over hypotenuse. And so we could say that the cosecant is the hypotenuse over the opposite. So I know that the ratio of the hypotenuse of this triangle that I'm drawing over the opposite side needs to come out to be x. So I just need to choose a hypotenuse and an opposite side so that the ratio comes out to be x. And I think the most natural choice is to pick x for a hypotenuse and 1 for our opposite. And you can check, what is this ratio of x over 1? It simplifies to give us this x here. Folks, if you're still having trouble with how I use this right triangle to help me make some statements, please email me, let me know. Okay, so this right triangle is nearly solved for. We know the angle, we know the hypotenuse, we know the length of the opposite side. We're going to find the missing side here by using the Pythagorean theorem. Recall that we have a squared plus b squared equals c squared. That's the sum of the squares of the two legs equals the square of the hypotenuse. And so if I were to plug in x for my c and 1 for either a or b, and then solve for the remaining side, I'd have that the remaining side is the square root of x squared minus 1. Okay. So now we can go ahead and give the derivative of the inverse cosecant function in terms of just x, and we have y prime is equal to minus 1 over, so this is the cosecant of y, which we said was equal to x. Because we're not being very careful with our domain, we need to go ahead and actually put an absolute value on that. If you have any questions as to why we need an absolute value on that, please let me know and I'd be happy to explain that further. And then we get times the square root of x squared minus 1. And there is our derivative of the inverse cosecant function. Folks, if you have any questions on this, let me know. But you should begin to see that this is sort of the same process for every one of these inverse trig functions, where we're given an inverse trig function statement. we rewrite it as its equivalent trig function statement. We implicitly differentiate both sides. Then we are left with an equation that involves y prime, and we solve that equation for y prime. At this point, we're sort of stuck until we can replace these trig expressions of y in terms of x. Well, right off the bat, I knew that the cosecant of y was essentially equal to x, although I needed an absolute value on that. And for the cotangent of y, I had a little bit of work to do. What is the cotangent of y? Well, the cotangent of y is equal to the, well, let's see, your tangent is the opposite over adjacent, so cotangent is the adjacent side over the opposite side. That is the ratio of the adjacent side over the opposite side. My adjacent side here is the square root of x squared minus 1, and my opposite side here is 1, and that reduces down to the square root of x squared minus 1. And that's why I went ahead and plugged this in place of where I had the cotangent of y. If you have any questions on that, let me know. Thank you.